Yes, hello, good evening, everyone. Welcome to another lesson. Today, we'll be doing some analytical geometry questions, question 3 and 4 of the papers. So I'm planning to do two papers today. Let's start with this question, question number 3. The figure below represents triangle ABC with A coordinates 3 and 8, B coordinates 17 and 6, and C 5 and negative 6. The altitude AD cuts the median BM at P. So 3.1 says determine the coordinates of M, the midpoint of AC. So when you look at the formula sheet, you'll see the formula for midpoint, x1 plus x2 over 2n, y1 plus y2 over 2. So for 3.1, our coordinates M going to be A and C. 3 plus 5 over 2 is 4. And 8 plus negative 6 over 2 is 1. Okay, positive 2 divided by 2, you'll get 1. 3.2, the length of MB. So since we already got coordinates of M as 4 and 1, and B is here, so if we apply distance formula, MB square will be equal to 4 minus 17 square plus 1 minus 6 square. So from this, MB is equal to, what's that? 13 square is 169 plus 25, 189. That would be 169 plus 29, 180, 194. It's square root 194. 3.3. The equation of the median BM. So in order to get equation, since equation of straight line is y is equal to mx plus c, we need the gradient of this line and a point. We can either use m or b. So let's find out m first. So gradient of mb will be equal to 6 minus 1 over 17 minus 4, which will be 5 over 13. And then after you get gradient, you can either use point M or point B. It's up to you. So let's use point B. So y minus 6 is equal to 5 over 13 times x minus 17. From this, y is equal to 5 over 13 x 5 times 17 plus 6 times 13. Other than 5 over 17.
Minus 7 over 13.
What's that?
Minus 7 over 13.
No, I got 43 over 13. How did you get that, Tivaştan? You multiply 5 over 13 by 17. Sorry, yes, I put 7 here. Yes, it is minus 7 over 13. And then 3.4. If CE is drawn parallel to AB, if CE is drawn parallel to AB, such that ABEC is a parallelogram and E is in fourth quadrant. So E is fourth quadrant. It's going to be somewhere here. And then question says CE will be going to parallel to AB. Okay, and ABEC is a parallelogram. So if you join E This will be parallel to AC. Determine x coordinate of E. So in order to get x coordinate here, you know that one of the properties of parallelogram, diagonals bisect each other. So midpoint of BC and midpoint of AE will be equal to each other. So if I find out midpoint of BC, that's going to be 17 plus 5 over 2. Right, that's going to be same as x plus 3 over 2. So x plus 3 over 2 will be equal to 17 plus 5 over 2. From this, x is equal to 22 minus 3, 19. So normally they could have asked you about y coordinate as well, but in this case it is just x coordinate. So if they asked about y coordinates, then it would be y plus y, 8 plus y over 2 is equal to negative 6 plus 6 over 2. From this, y would be equal to negative 8. Okay. Just in case that they asked about y coordinate. This next question, 3.5. The equation of the altitude AD. The altitude AD cuts the median BM at P. Right, altitude means height of the triangle that will be perpendicular to side BC. So what is the gradient of side BC? Gradient of BC is, did we find gradient of BC or is it given? No. Okay, let's find out gradient of BC is 6 plus 6 or 17 minus 5, which would be equal to 12 over 12 is equal to negative 1. So gradient of this line is negative 1. And since this is altitude, that means this angle is 90. So AD is perpendicular to BC. So from that, gradient of AD times negative 1 is equal to negative 1. From that, gradient of AD will be equal to 1. After you get gradient of AD and point A is on this same line, so we can use coordinates of A. So it's going to be y minus 8 is equal to 1 times x minus 3. Y is equal to x minus 3 plus 8,
So
x plus 5. Yes,
won't the gradients of BC be equal to 1?
you're right. I made a mistake there. Thank you. That would be 1. This would be 1. That would be negative 1. So that will change this one now, negative 1. So positive 3, that's going to be x plus 11. Thank you. Negative x plus 11. Okay. Or you can find out the c value. So you can say 8 is equal to negative 1 times 3 plus c. C is equal to 11. And then you can find out the ratio as negative x plus 11. Okay, it's up to you. Now 3.6, the coordinates of P. The coordinates of P, as you can see, it's 4 marks. So P is here, intersection point of MB and AD. Okay. So we just found out now gradient of AD was negative x plus 11. equation of equation of AD was negative x plus 11, and equation of MB we found in the previous question in 3.3. It was 5 over 13 x minus 7 over 13. Okay. So if you solve this equation here, when you multiply both sides by 13, you'll get negative 13x plus 143 is equal to 5x minus 7. If you simplify this, negative 18x is equal to negative 150. So if you continue here, if you simplify that, x will be equal to 25 over 3. Right. So since it says coordinates, that means you need to find out x and y. So in order to get y, you substitute 25 over 3 for x in the equation, in one of the equations. So if you solve this, y will be equal to 8 over 3. Okay. Any questions, Diverston?
No, sir.
You're all okay.
Yes.
All right. Let's do now second question in analytical geometry, which is about analytical geometry of circle. Question number 4. In the diagram below, the large circle with center A has the equation x squared minus 2x plus y squared plus 6y is equal to 15. A smaller circle with the equation x minus 1 squared plus y minus b squared is equal to 1 touches the larger circle at E. The larger circle cuts the x-axis at B and C. The area of the triangle ABC is shaded. Determine the coordinates of center A. Right. Can you see this? Like we solved many questions in class as well. This question always comes in analytical geometry of circle, where you need to use completing the square to get the coordinates of the center and the radius here. So 4.1, let's do it here. Right, 4.1. So these two here, binomials. So in order to make this trinomial, I need to add a number here. So x squared minus 2x, it's always half of coefficient of x squared. So 2 divided by 2 is 1, squared is 1. So we need to add 1 to this. So this part here, we need to add 6 over 2 squared, which is equal to 9. So y squared plus 6y plus 9 is equal to 15. So since this is equation, we added 1 and 9 here. That means we added 10 on the left-hand side. So we must add 10 on the right-hand side. So this is trinomial here. And you can simplify that as x minus 1 square. And this part is also trinomial. So you can simplify that as y plus 3 square is equal to 25. So from this, coordinates of A will be 1 and negative 3, and R will be equal to square root of 25, which is 5. Okay, that's 4.1. Determine the coordinates of B and C. So coordinates of B and C, these are x-intercepts of the circle. X-intercept means y coordinate is 0. So we need to substitute 0 in the equation of circle. So 4.2 x minus 1 square plus 0 plus 3 square is equal to 25. From this, x minus 1 square is equal to 25 minus 9 is 16. If you solve this quadratic equation, x minus 1 is equal to 4, or x minus 1 is equal to negative 4. X will be equal to 5, or x will be equal to negative 3. So negative 3 obviously will be b, since it is on the left hand side. So coordinates of b are negative 3 and 0, and coordinates of c are 5 and 0. 4.3, determine the equation of the tangent to the larger circle at C. Determine the equation of the tangent to the larger circle at C. So that means we have a tangent line to the larger circle, which is going through at C. So coordinates of C we just found out as 5 and 0. Coordinates of A were 1 and -3. So this is our radius, that's our tangent. So you know about tangent and radius, you know the theorem. Radius is always perpendicular to tangent. As a result of this, gradient of tangent times gradient of radius is always equal to -1. So we can figure out gradient of radius by using these points. So that's going to be 0 plus 3 or 5 minus 1, which would be or times gradient of tangent is equal to -1. 3 over 4 times gradient of tangent is equal to -1. From this, gradient of tangent will be -4 over 3. So after you get gradient, we can find the C value. So Y value is 0 is equal to -4 over 3 times 5 plus 3. From this, C is equal to 20 over 3. So then equation of tangent will be -4 over 3x plus 20 over 3. Right, 4.4, determine the value of B. Where is B? B is y coordinate of the center of the smaller circle. Right, since these two circles touches each other like externally, when I draw the radius here AE and radius from E to the center of this circle here, coordinates of this circle are 1 and B. Okay, I can tell from the equation, from when you look at this equation here, the coordinates of center will be 1 and B. So we just found the radius of this larger circle was 5. The radius of smaller circle, by looking at this equation here, you can see it is 1. So distance between these two centers is equal to 6. So if you apply distance formula here, actually you don't need to apply this because the x coordinates are same, like 1 and 1. So it's going to be, when you subtract that -3 minus b must give you 6. From this, b will be equal to -9. Okay. The vertical distance between A and this center of small circle must be 6. So when you subtract 3 minus b, you must get b as -9. Right. 4.5, determine the size of theta. Or, like, if you didn't understand that, you can use distance formula for 4.4. You can say 1 minus 1 square plus -3 minus b square is equal to 6 square. And then if you solve this equation, -3 minus b is equal to 6, or -3 minus b is equal to -6, b is equal to -9, or b is equal to 3. Obviously, it can't be 3 in this case. It has to be, this is non-applicable, right? Then it has to be -9. Yes, 4.5, determine the size of theta rounded off to one decimal place. Assume that theta is an obtuse angle. So this is trigonometry and analytical geometry combined here. So R here is 5. This side is also radius, that's also 5. And we have the coordinates of B, which was, what was the coordinates of B? negative 3 and 0. So that means OB is 3 units, OC is 5 units. That's all together. That is 8 units. Right. So we have a triangle with sides 5, 5, and 8. Theta is here. So in any triangle, if you know the three sides, you can always work out the angles by using the cosine rule. So if you look at the formula sheet, you'll see that 8 square is equal to 5 square plus 5 square minus 2 times 5 times cos theta. And then this will be 50 times cos theta is equal to 50 minus 64. Cos theta is equal to negative 60, negative 14 or 50. So if you use shift cos negative 14 over 50, that's going to give us theta is equal to 106, comma 3. Okay, since it says round off to one decimal place. Or if you couldn't see that, you can just draw this perpendicular height here. So this side will be 3 units, that side will be 4. You can find out this angle here as tan theta is equal to 4 over 3. And this is also going to be like 4 over 3 tan theta. We can say or tan theta is equal to 4 over 3. Shift tan theta is, what is shift tan theta 4 over 3? Shift tan 4 over 3. 53, comma 13. If you multiply this, 2 times theta is 106, comma 26. If you round it off, you'll get 106, comma 3. Let's call this like another angle, beta, right? Then it makes sense. So if it is beta, 2 beta will be equal to theta. Okay, that's another way of finding that. Determine the area of the unshaded part of the larger circle. Unshaded part of larger circle. So we can solve it here. Let's change the colors. 4.6. So unshaded part will be everything in this circle besides this triangle here. So uh, unshaded area will be the area of circle, which is 25 pi, right? 5 uh, pi times 5 square, which is 25 pi, minus area of ABC. So that will be 1 over 2 times base is 8, height is 3, so 25 pi minus 12. Okay, if you use your calculators, that's going to be 66, comma 54 units. Right, let's have a look at another question. ABCD is a trapezium with vertices A, B, C, and D. K is the midpoint of AC and BA is parallel to CD. Write down the coordinates of K. So that's going to be like easy, 2 marks. For K, midpoint of A and C, 5 plus 5 over 2 is 5. 13 plus -1 is 12, divided by 2, 6. The coordinates of K would be 5 and 6. Okay. 3.2. The gradient of AB, again, another easy 2 marks. Why? Because the coordinates are already given. So gradient of AB will be equal to 13 minus minus 8 is plus 8, or 5 minus minus 2 is plus 2, 21 or 7, which is equal to 3. 3.23, this is 3.2.1, 3.2.2. Calculate P if coordinates of D are P and P. They are equal to each other. So since parallel lines are given, the coordinates of the gradient of AB is, look, gradient of AB will be equal to gradient of CD. That's going to be equal to 3. Why? Because of parallel lines. Now I can also define gradient of CD by using the coordinates of D and C. So P plus 1 or P minus 5 is equal to 3. From this, P plus 1 is equal to 3P minus 15. 16 is equal to 2P. And from this, P is equal to 8. 3.3. ABED is a parallelogram with E, a point in the fourth quadrant. ABED. Right, so E will be somewhere here. So that ABED is a parallelogram. Calculate the coordinates of E. Again, exact same question as previous question. Since this is a like now the coordinates of D are 8 and 8. Since ABED is a parallelogram, that means when you draw these diagonals will have same midpoint. So if you say coordinates of A, E as x and y, x plus 5 or 2 must be equal to -2 plus 8 or 2. From this, x plus 5 is equal to 6, x is equal to 1. For y coordinates, y plus 13 or 2 must be equal to -8 plus 8 or 2. From this, y plus 13 is equal to 0, and y is equal to -13. So coordinates of E will be 1 and -13. 3.4. Calculate the area of obtuse ABC. Area of obtuse ABC. Yes, in order to get this, we need to, is it right angle triangle? No. So we need to find out the angle here. How do we get this? For a 3 mark question. The coordinates of A and C are same, the x coordinates. Yes, so for a 3 mark question, we don't need to find out an angle here because here when you extend AC, right, and you can draw height for that circle from B to this line here. This is height, right, and then you can use AC as base. So our length of base would be 13 plus 1, which is 14 units, and then height would be perpendicular height would be negative 2 plus 5, which is 7 units. So 3.4 area triangle ABC will be equal to 1 over 2 times 7 times 14, which is equal to 49 units square. 3.5 ABC is reflected in the line x is equal to 5 to form AFC. Calculate the perimeter of ABF. Yes, right now, what's our like x coordinates of this point are 5 and negative 8. So this would make this side is 7 units because from negative 1 to negative 8 it's 7 units. So we can work out AB square in this triangle, right? And also let me draw the reflected part as well. So if we reflect, this is the line, right? This is the line x is equal to 5. So if you reflect AB C, you're gonna get the reflected part here. That's gonna be F. So coordinates of F will be 7 units away from 5, which would be 12 and negative 8. So question is calculate the perimeter of ABF. So I need this side here AB, AF, and BF. So 3.5.1. So we can find out AB first. AB square is equal to 7 square plus 21 square. From this, AB is equal to, what's it? 7 square plus 25 square. It's 7 root 10. 7 root 10. So coordinates of F are 12 and negative 8. So from that, we can get the distance BF is 12 plus 2 units, which is 14 units for BF. And then AF also will be same as AB. That's also 7 root 10. So perimeter AB F will be equal to 7 root 10 plus 7 root 10 plus 14. Okay, which is 58,27 units. Determine the equation of a circle centered at O, the origin, passing through point F. So if this is the center passing through F, it's going to be this way. So that means OF will be our radius. So that means we need to find out the radius r square is equal to 0 minus 12 square plus 0 plus 8 square. Then from that, r square will be equal to 208. Then, since coordinates of center is origin x minus 0 square plus y minus 0 square is equal to 208. If you simplify that, x square plus y square is equal to 208. Okay. So that's all for today. Let's end it here. I'll see you at another lesson. Enjoy the rest of the day. See you next time.
This is
Thank you.